Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, students. Here is another problem in Vitamath 86, a problem that challenges those who are through with calculus, both differential and integral calculus, engineering graduates. So this will test engineering graduates of how they retain their knowledge in calculus. And for those who want to anticipate the solution, or you want to those who want to solve this problem, you may do so by pausing the video. Do not look at the solutions. For the region bounded by 9y equals x squared, which is a parabola open upward vertex at the origin, and x equals 3 is a vertical line 3 units to the right of the y-axis, and the x-axis, or y equals 0, the horizontal x-axis. Determine the following: the moment of inertia of area with respect to the x-axis, the moment of inertia of area with respect to the y-axis, the moment of inertia of area with respect to the origin, the moment of inertia of area with respect to the line x equals 5, the moment of inertia of area with respect to the line y equals 2. So first, let's plot the curve. You may have point plotting. That's a parabola with vertex at the origin. You should know the graph. And the line x is 3 is a vertical line here. And the x-axis is y equals 0, or the x-axis. So that's the shaded part. And moment of inertia with respect to the x-axis. So we make the strip parallel to the x-axis so that we use moment of inertia equals integral of distance square, which is every element of the horizontal strip, which is this, is equidistant from the x-axis, and the distance is just y. So y. So therefore, ix is integral of y squared differential area. And since the distance of this point from the y-axis is in general x, and this vertical line is x equals 3, so that means it is all points on this vertical line are 3 units to the right of the y-axis. So if this is x, then the length of the strip is 3 minus x. The thickness is dy. The variable of integration is y. Therefore, the limits would be from 0 to 1. So ix is integral of the square of the distance of any point on the strip from the x-axis, which is y, so y squared dA. And dA is the area of this strip, which is length 3 minus x, thickness dy. Since the variable of integration is y, we replace x by square root of 9y, or 3 square root of y. So y is integral 0 to 1 of y squared, quantity 3, minus x, and x is 3 square root of y, or 3y to the 1/2 dy. You can use your calculator, but let's factor out 3, integral 0 to 1, quantity y squared minus y to the 5/2 dy. So integrating now, so you have 3y cubed over 3 minus y to the 7/2. Reciprocal of 7/2 is 2 over 7, 0 to 1. So don't mind the variable because it is still 1. 1/3 minus 2 over 7 times 3, that would be ix equals 1 over 7. Then if we consider the vertical strip, so that's 9y equals x squared, vertical strip, then it is just a rectangle with respect to the base. The base is dx, the height is y. So therefore, the moment of inertia of rectangle with respect to the base, if you can recall, 1/3 base height cube. So that's why you have ix integral from 0 to 3, 1/3 base is dx, height is y. So 1/3 dxy cube. 1/3, then replace the variable of integration this time is x because the differential is dx. So limit 0 to 3. Then we replace y by x squared over 9 quantity cube dx. So that would be 1 over 3 times 9 cube. X to the 6, integral of x to the 6 dx is x to the 7 over 7, 0 to 3. So that would be 3 to the 7 minus 0 to the 7, so 0. 3 to the 7 over 3, all over 3 times 9 cubed times 7. So Ix is still 1 over 7. Then B, the moment of inertia of area with respect to the y-axis. So this time, let's consider first vertical strip so that every element of this vertical strip from the y-axis is x, the constant distance is x. And moment of inertia is integral of constant distance square dA, if you can remember, distance square dA. So Iy is integral of constant distance square x square dA. dA this time is area of this rectangular strip y dx. Replacing y, so integral 0 to 3 because the variable of integration is x, x squared, then y is x squared over 9 dx. So you may use your calculator this time. Integral of x to the 4th over 9 dx 0 to 3, 27 over 5. Or if we consider this horizontal strip, it is just moment of inertia of big rectangular strip of height 3 units, thickness dy with respect to the y-axis, then minus the moment of inertia of this dashed rectangle with respect to the y-axis, 1/3 dy x cubed, while the moment of inertia of the big rectangle, 1/3 dy 3 cubed. So we have Iy equals 1/3 dy 3 cubed minus the moment of inertia of this rectangular dashed rectangle with respect to the y, 1/3 y x cubed, 1/3 dy x cubed. So factor out 1/3, then we'll have integral 0 to 1. Y is the variable this time because of dy. Then we have 27, 3 cubed 27 minus x cubed dy, replacing x terms of y, it is 3y to the 1 half. So x cubed is 3 cubed y to the 3 halves. So Iy is 1/3 integral 0 to 1 of quantity 27 minus x cubed, and x cubed is 27 y to the 3 halves. So that would be 20, factor out 27 over 3, so 9, then 1 minus y to the 3 halves. You can evaluate the integral as y minus 2/5 y to the 5 halves, or you may use your calculator. It will give us the same answer of 27 over 5. Then moment of inertia of area with respect to the origin, it is simply Ix plus Iy. So we already computed Ix 1 over 7. That's also Io, Jo, or polar moment of inertia. Ix 1 over 7, Iy 27 over 5. That would be 194 over 35. Then letter D, the moment of inertia of area with respect to the line x equals 5. So this time, let's consider vertical strip so that the strip is parallel to that vertical line. The distance, because that is x and this distance is 5 units from the y-axis, so this is 5 minus x. The constant distance is 5 minus x, and the differential area is y dx. So I, with respect to x, is 5, integral 0 to 3, variable of integration again is x because of dx. Constant distance 5 minus x square, then differential area y dx, replacing y by x squared over 9. And instead of expanding, you may check by expanding, then integrating. But because this is calculator aided, this problem is intended for those who will take the board exam in the Philippines, unless you are a high school student or a student in calculus where calculators are not allowed. Then you have to expand this first, then apply power formula. So again, calculator aided, integral 0 to 3, you will get 79 over 10 or 7.9. Then finally, the moment of inertia of area with respect to the line y equals to there. So this time, let's consider horizontal strip so that the strip is parallel to that line y equals to. So since this is y and y equals to is 2 units above the x-axis, therefore the constant distance is 2 minus y. So I with respect to y equals to equals integral y is the variable of integration this time, 0 to 1 limits. Then constant distance 2 minus y, so quantity square dA. dA is 3 minus x dy. So 2 minus integral 0 to 1, 2 minus y quantity square, 3 minus x dy. Again, we replace x by 3y to the 1 half. Then use your calculator instead of expanding. Uh, if you want to expand, then it's the better to verify that this is the answer. So using your calculator, it is 103 over 35. So that's it for this video.